Good afternoon and welcome to Ask the SCSA Toolbox Tuesday. My name is Justin Brooks, Safety Advisor for the SCSA, and I'll be presenting today's Toolbox Talk. Before I start the presentation, I just want to take a moment to discuss a few items before we get going. All right, so this presentation is being recorded and will be available for later viewing on Facebook and our YouTube channel. So if you're not following our social media accounts, make sure that after this presentation, give this video a like and a share and follow our pages to keep up to date on safety in Saskatchewan. All right, so what I will be presenting on today is actually some innovations in safety. And one of those innovations that I will be focused on will be drones, believe it or not. The use of drones in safety and for inspections and other uses in the construction field. So I'm just going to be sharing my screen here real quick. You're going to hear the term UAVs often. So that stands for unmanned aerial vehicles. All right. So UAVs, often called drones, are increasingly used for military, recreational, public, and commercial purposes. UAVs have the potential to prevent injury and death in the construction industry. Advancements in UAV technology could help reduce construction-related injury and death from falls, toxic chemical exposures, electrical hazards, or traumatic injury from vehicle and equipment collisions. According to the United States Drone Market Report in 2019, the U.S. commercial drone market is growing rapidly and expected to quadruple its size in 2024. Again, that's just the United States itself alone. As more businesses look to take advantage of commercial opportunities that drone technology brings, commercial investment in this tech segment will continue to grow. Many features of drones, including precise controls, computer vision, object avoidance, tech flight planning, GPS capabilities, geofencing, huge carrying capacities, and artificial intelligence, make the industrial-grade models capable of fulfilling many commercial construction purposes. When deployed properly, drones can easily perform a wide range of roles that were previously considered labor-intensive and time-consuming. One particular sector that this is one of the first to harness the benefits of drone technology is the construction industry. In fact, drones are quickly becoming regarded as vital to improving construction site safety. So, as is the case with other emerging technologies, occupational safety assessments of UAVs lag behind technological advancements. Now, consider that UAVs may create new workplace hazards that need to be evaluated and managed to ensure their safe operation around human workers. A recent paper from the National Institute for Occupational Safety and Health in the American Journal of Industrial Medicine, Unmanned Aerial Vehicles in Construction and Worker Safety, describes the four major uses of UAVs, including their use in construction, the potential risks of their use to workers, approaches for risk mitigation, and the important role that safety and health professionals can play in ensuring safe approaches to their use in the workplace. So the article provides a wealth of information on the major uses of UAVs. This will focus on UAV use in construction. The commercial segment of the $100 billion UAV market is predicted to be the fastest growing market between 2016 and 2020. Now we see with it growing into 2024. By 2025, the U.S. commercial UAV sector is forecast to surpass $5 billion in investments. The emerging uses of UAVs in the construction industry range from aiding with construction project planning by aerial mapping of the construction site to extending the actual building of structures. The most common UAV uses in construction are described in the next few slides. So, first up is monitoring. Monitoring a large construction site is a challenge for construction management. The UAV can be deployed to send video footage to site conditions to construction management faster and more efficiently than can on-the-ground personnel. Video can be converted into three-dimensional pictures of the site and then compared to computerized architectural plans to show how accurately the project is progressing. Monitoring information obtained by a UAV also serves as a useful input into the preparation of periodic construction progress reports. UAVs can be equipped with far and near infrared cameras, radar or laser-based rangefinders, which can greatly enhance their surveillance and monitoring capabilities at the construction site. In addition, tracking moving objects on construction sites such as people, equipment, and material are being developed, as well as equipping UAVs with the capability of mapping indoor construction environments. Next up is inspection. So often UAVs can inspect a large worksite more efficiently through aerial photography than on-the-ground personnel can. UAV detection of hazardous conditions, materials, and dangerous structures can aid in construction site identification without placing a worker at risk. Real-time UAV systems performing remote site inspections and violation detection at construction sites may be more efficient, safer, and less costly than present construction site inspection methods. UAV inspection of awkward location on and under bridges and along highways can not only reduce the personnel inspecting the entire expanse of highway and road or structure, but also reduce the risk of working along a busy highway or erecting equipment close to the flow of traffic. Government inspectors of a construction site could also be performed by a UAV. Because inspection of the site would be quicker than an individual government inspector walking an extensive construction site, UAVs could increase the scope and frequency of inspections of construction projects by federal and local government agencies. Once potential violations were identified by aerial imaging, the inspectors could focus their investigations on site where the potential violations were imaged. Maintenance. So using UAVs in carrying out planned or reactive maintenance inspections of tall structures, such as skyscrapers, bridges, and towers, where access can be costly and pose a risk to workers from falling from a great height, appears to be a clear benefit for construction workers. So other uses of UAVs have been proposed as material handling vehicles, transporting tools, equipment, and materials at construction sites, or used to spray paint a waterproof, I guess I should say, a structural component. UAVs can also be used to capture unique views of a structure for promotional photographic purposes. While there are many benefits to using UAVs in construction, the potential risk must be carefully studied. The presence of a UAV flying in close proximity to a human worker can create a new hazard at a construction site, although data supporting the hazard potential of UAVs for workers are scarce. Safety professionals need to be aware of these new hazards, assessing the risk arising from them, and apply controls to reduce risk. There's been little published about the safety and health risks associated with the public or commercial use of UAVs. We only have the data on how long they've been flying for in this commercial sense, and there's not a lot. However, the military has begun to assess the adverse health effects among remote pilots operating UAVs over conflict areas and reported stress reactions in military personnel arising from their work as UAV operators. These are obviously much different scenarios, but this data may have some relation to just purely stress from operating these vehicles, right? So that is something to watch out for. About 30 incidents of near misses or crashes leading to human injury have been reported associated with the use of recreational UAVs. This, again, is in the States. There's not a lot of data in Canada as of yet with using UAVs in construction, as a side note. Unstable flying conditions, operation errors, and faulty equipment may represent a potential hazards to nearby workers from commercial use of UAVs. Adding to the uncertainty about the hazards to workers from the emerging use of UAVs in construction and other industries. The arrival of autonomous or semi-autonomous UAVs may introduce new hazards arising from the absence of human control. It's important to develop hazard identification, risk characterization, and mitigation approaches to ensure the safe operation of commercial UAVs, as the use of UAVs promises significant benefits for the industry. These approaches may incorporate prevention through design concepts such as lightweight manipulators, passive compliance systems, safe actuators, passive robotic systems. Navigation and collision avoidance systems can be included in the design of commercial UAVs as a proactive safety measure. Collision avoidance in the three-dimensional environment is the main area of UAV design research. Structural designs should consider stiffness and pliability factors that can reduce the impact force during collisions. Tools for the evaluation of UAV safety during the design and certification stages are being developed. So look out for that. Adequate training of operators is essential to ensure the safe operation of the UAV. A competent UAV operator is a person capable of identifying any potential hazards of operating a UAV in the particular construction site surrounding. This especially any UAV operating condition that poses a hazard to workers on the ground. Competent UAV operators should be authorized by the construction manager to take prompt corrective measures to eliminate any hazard associated with the operation of the UAV. Transport regulations, they had changed in June 1st, 2019. If your company operates drones at construction sites, it's important to be thoroughly informed and in compliance with these requirements to avoid heavy penalties. These regulations apply to all drones weighing between 25 kilograms and 250 kilograms. So firstly, drone operations are now classified as either basic or advanced, rather than recreational or commercial. For both categories, though, drone pilots must register and mark the drone with its registration number, pass an online exam, and get a pilot certificate, stay below 122 meters or 400 feet above ground level, stay away from air traffic, carry their pilot certificate and proof of registration during flights. You're considered to be conducting basic drone operations if you meet all three of the conditions. You're flying the drone in an uncontrolled airspace, you're flying your drone over 30 meters or 100 feet from bystanders, and you are not flying your drone over bystanders. Drone operations falling outside of any one of the above conditions will be considered advanced, and the pilot will be required to meet other conditions, such as passing an exam and flight review. Many of the construction site activities using drones can be classified as advanced. It's no different than when we talk about first aid. We say most construction sites are going to be at a moderate risk level, and that's going to determine the first aid kit you have, as well as within these conditions, most construction sites will fall underneath the advanced. It's also important to be aware of other applicable rules and regulations that apply. The Canadian Aviation Regulation specifies maximum altitude and horizontal distance from bystanders, pre-flight site survey procedures, minimum weather conditions, and record-keeping requirements. Those planning to operate outside these rules or fly drones weighing more than 25 kilograms will require a special flight operator certificate from Transport Canada. An SFOC will also be required for carrying dangerous or hazardous payloads, flying at special aviation events or an advertised event, flying more than 5 drones at the same time. Fines that can be imposed on corporations for incompliance include up to $5,000 for flying without a drone pilot certificate, up to $5,000 for unregistered or unmarked drones, $5,000 for flying where you're not allowed, and up to $15,000 for putting aircraft and people at risk. As the use of public and commercial UAVs gain in popularity, it'll be important to review their uses and ensure that hazards and risks to workers are identified and controlled. Collecting and analyzing objective data about negative safety outcomes in the future will also be important. Safety professionals, organizations, and government adopt a proactive approach with the integration of UAV technology and work collaboratively to develop best safety practices that can promote the beneficial use of this promising new technology in construction and other industries, while at the same time ensuring the safety of health and safety of workers working with, nearby, and below these new workplace tools. So it's absolutely important that, even if this does make inspections safer for those conducting inspections, we also have to make sure that there's a high level of safety for the people that are not conducting these inspections, that are just working, right? We want to make sure that there's no collisions, and then it's not distracting workers as well. So that becomes something of great importance. That's it. That concludes our SCSA Toolbox Tuesday. I'd like to take a moment and thank all of you by watching and participating in these discussions. We're all working together in making Saskatchewan the safest construction environment in Canada. Make sure you tune in next week for Toolbox Tuesday at 10 a.m. or our Wednesday webinars, which are the first Wednesday of every month at noon. I also want to remind you that we have all our presentations available on our YouTube channel. These are a fantastic resource for training and toolbox talks. Even if, unlike us, you're not doing meetings online, these are still a great resource for your job site. Remember to like and share this video and follow us on social media platforms. So have a great day, everyone, and work safe.